Okay, so yeah, I was told by a friend to actually make a video that was showing one of these things growing, and I did. I just made this quick little 20-second video on YouTube of a 20-step process of one of these growing for 20 steps, and I threw up a thing on r slash r Cellular Automata on Reddit, and I also put up like just a couple things on my own socials, and yeah, so far it's got like 90 something views, and it's only been 19 hours since it's been up. It's like my most successful video so far. So thanks everybody who came and watched the video. If you're watching this right now, thanks again. I guess the better YouTube likes me, the better I can get this type of stuff out and share it with people. So anyway, yeah, I just wanted to go into just a little bit in this video some things that were mentioned in some responses, things that, let's see, I'm gonna go find, yeah, I'm gonna go find that real quick. Okay, so I found this. So yeah, I actually, on this Reddit post in Cellular Automata, I actually responded to this guy, but his question was, how did I figure out the parameter? Like, what did I do to find the parameters to grow it like this? And that's sort of what I was messing with in order to get this. I made a longer video. I haven't actually edited it yet, though, and I think that it was a little bit way too long because I messed with a lot of different parameters and showed a lot of different things. If people like maybe make some comments or something or ask me to show that, then I'll show that. So let's see. I'm going to go into just that exactly. So the question is, I'm curious what you find, where you find. This is by Build It Better. Hi guys. These are really pretty. I'm curious where you find the parameters for the update and growth rules to make these. Care to share any details? So I do share some details in here. That can be, I'll put a link to this this thread in the video. But I mentioned a point in the code on my GitHub where it shows the parameters, and I start to explain the parameter class. So I just wanted to make a quick video explaining that. This parameter class, it's mainly all in here, but just to show it visually, like what changing these parameters actually does. That's what I wanted to do. So the here we go. Very simple one. I guess you guys could read that. It's kind of TLDR. So to explain, the min and max should always be set if function is set to something. So okay, what I'm trying to say there is here in the code, I've got my parameters set up. Now the parameter class is just something that is literally, this is all it does. You can make a copy of it, and the copy can inherit the count. That's what allows this to happen. You see where, okay, this main stock here, when it first starts out, I really love the way this thing, like the current parameter setup that I have for these these stocks are pretty out there. Anyway, so look at this. It turns from this into one of these direct stocks here, and then grows a little two more there. And you might be wondering, and so this also, if you notice, these two are at like a specific angle, whereas the ones over here are at a different angle, and this guy has like two of them close together and stuff like that. Now you would think that maybe this is random, but this is not at all random. This is just a higher level. This is just a higher level of order because of the way that the parameter class works. So what the parameter class does, it allows you to step over by using the next function to get to the next parameter. I actually want to start using this in more things that I do. But anyway, the point is that what happens is every time that you call that next function, I kind of hate Blender's Blender's implementation of the text editor. I really wish they could like do something to be more like Sublime. But I mean, they did a good job, and I guess they're not, they're open source too, and they're definitely not like a focused on just scripting or something like that. Even though, I mean, I love that Python is a big part of Blender. Don't get me wrong. So, all right, now we're gonna try to find the here we go, tip. Okay, the hormones. I haven't even got into hormones yet. That's for later, because I haven't even really touched it yet. But it's going to be pretty cool. Like they'll be able to share hormones as like volumes of hormones and stuff. Anyway, back to this. So when I call the next function, I can't get seem to get, or the last time I tried to use the search function in this, it was just kind of weird and funky. So that's why I was talking about Sublime earlier. Because I'm so spoiled now. Let's see, tip, cell res, curve slice, DNA. Okay, so if you notice, everything has DNA, and that DNA is basically just this big ass list of params right here, and yeah, so that's the class. But anyway, I call them in next. There's this function called p-tuple next. Because everything that's a parameter function starts with p underscore. So p underscore tuple underscore next function allows you to take a tuple of parameters and just get the next of all of those parameters. And remember, since these are objects in Python, they're actually a reference. Like this is a reference to the object, so you can just store these references in a list and it's not going to take up any extra memory, which is great. So anyway, here we go. I've tried to comment these all out, and I think in the current GitHub, these aren't commented like this, but you can see them here. It's the same thing, just X and Y. So let's see, we've got section height, branch number, and we've got a couple of other things here. So what we have here, we've got section height, branch number, radial branch angle, tip growth ratio, branch inclination. The video that I released earlier was there was a difference here in radial growth rate coefficient, and I also have a screenshot on my GitHub that shows 3 plants, and it shows the different settings with this 13th parameter inside of the branch. I don't know, you could call it genome or something like that in the gene. This might not be called self DNA, this might be called self gene, and then each of these are like the different pieces of, I don't know. Anyway, I'm not a geneticist, so don't quote me on any of this stuff. The point is that we've got here that radial growth rate coefficient and p ln r from 2.0 starting at starting at 2.0 and working down by 0.5 down to down to 0. From 1. So anyway, p ln r is this function up here. I'll just show it to you directly. These are all of the parameter functions. So p ln is for linear. So what that does, it just adds the frequency number to the value, and once it's over the maximum, then it loops. Everything here is what I call a step infinite series. Like everything here is what I call a step infinite series function. So basically what it is you've got a Well, besides PRNG, which is used to give the ranges back on some of these, for like to put those within the min-max range. For instance, with the sine wave function. So, I mean, I'm using Desmos here, so y equals sin x, right? You've got this, but it does the sine wave so that it's between 1 and 0, plus 1 times 5, so times the frequency. So if you set the frequency, so x times the frequency, right, plus 1 minus 0.5, oh, plus, wait, sorry. What was it? Times. Okay. Multiplication. Okay, so that puts us between 0 and 1. And that's just something that's going to go like that forever. Anyway, so sorry about that big white screen there, guys. I haven't figured out, I guess, how to get Desmos into night mode. I think there is a night mode on there. So anyway, yeah, back to non-blinding stuff. So we've got here all of these ratio. So this is a ratio. It just multiplies by the frequency, so on and so forth. Everything here, this is a square function. Whoa, where, what? Square function didn't work. It should be, yeah. It should be the just an int, like a float of the int. Float int, I'm guessing. So that's going to get the range thingy back. It's going to return the value times blah, blah, blah. So, yes. Oh, okay. That doesn't need to be like that. That needs to be more like this. Oops. Okay, that's okay. Those are integers. Anyway, that needs to be more like this. The square needs to be... Okay, sorry guys. What this is going to do is basically it's going to go the sine times so on and so forth. So this is actually going to be the... integer version of all of that. So it's just going to jump between the two things that you put at the frequency that you put. So it's going to jump between the minimum and the maximum at the frequency that you put if you do a p square, right? Let's just... Okay, so first off, let's just go back real quick 1 second and do this param thing here. Param 3.0. Okay, so this is cell growth. This is also a radial growth ease rate while it's doing growth. So that's an ease rate towards neighbors, and then this is an ease rate away from neighbors. Then we've got your growth coefficients for x and y, and those also function on the cellular level. So those are multiplied in when the cell actually has the grow function. You can see that further up in the code. Point is, let's just do something real quick. We've got this guy aged to 10 growth steps. I've changed this around a little bit. Got this guy aged to 10 growth steps, and we're going to just go We're just gonna delete him because I mean we'll get him back anyway, right? Like, whoa, what did I do? Oh, because I'm using square, right? Because that was just being the sine function before. Okie dokie. Well, that is a really poor looking individual right there. But hey, at least he's like set up in a decent way. He's just like this little skeleton guy. I guess if he was a specific race, I guess he grows up this way, a specific type of species that uses the square function right there. But anyway, though, so instead of doing square, so that was the slice thing, and it's only between v min 0.005 and v max point. So if I were to literally do something here to change that, but what I'm going to do is this. I'm going to change the square function to the sine function. And since I didn't change square y or whatever, I'll just change all this stuff back to sine. Because that's what it was using anyway. So this, actually I could just make that cos and this could be the right thing. This is stuff that's going to have to be changed. So this will be cos as well. And I should be able to get back to where I was before. Let's delete this guy while he does teach us something that the square function works. Whoa. Who else is using the square function? Oh, this guy. Right, let's try you out. Oh, there you are again. Okay. All right, so now, anyway, what we can do, so you might notice here that I've got this like sequence of things here. This is the branching sequence. If we take a look at this object in edit mode, each one of these vertices is a cell. So these are like point cells in a cellular automata with point cells, basically. If you look up each branch, each layer here is a layer that has cells on it. So these are all slices, right? And these slices can slightly deform, so on and so forth, because of how cells move. But overall, you can pretty much count all the cells that exist by looking up right here, this parameter in cell portion of the DNA, the cell resolution. That's how many cells go around these little circles. Anyway, point is, if I change this to some functions plus some numbers, that'll also work. If I change this to just this branch number, right now this guy is using like 2, right? So let's just move him off. I'm just going to go ahead and get rid of the plane for a second. Move him off in the y direction. Just to get him out of the way. And then so we can compare him, and then I'm going to turn this to, instead of like 2, I'm just going to do it like 1, 1, 2, 3, right? And these act as like, think about it as if you were changing an equalizer or something like that, or basically like those sine. I won't load that big old white screen. But anyway, those sine waves or whatever. Think about if you had like an equalizer on a synthesizer or something like that, and you were just like making your own little curve. Well, that's basically what this is. You can just choose values that go in your little curve, and then as it steps, since these parameters, they go to their next value, whatever the function outputs or whatever this outputs, it goes to that next value and then just loops around. Or the function is continuous, so it just does something forever. There's a log function in there too, so it can be something that just goes towards an infinity that never comes. Anyway, so let's just go ahead and run this. And maybe not quite so immediately you can see the difference. There's less foliage on this guy. So yeah, so a whole bunch of less foliage, or whatever you want to call that stuff. There's a whole bunch less of that, and while he does still have, the same stock, because the cellular growth parameters are still the same, and the other stuff that has to deal with cellular growth. So the one thing I wanted to mention is that this radial growth coefficient, I might add a y version too, an x and a y version, so that it can do the same thing here as here. But these both, like all three of these, affect the cell growth. They're multiplied in. I mentioned that earlier. So all of those affect the growth. Those are multiplied in up here. Inside of the bifurcation, you can also see that I'm just calling the next of each one of these things. So because all of those are copies, so the parameter system has a function that like copies. This is really important too. If it's a copy, then this copy obviously is going to have its own counter inside of it, which allows it to keep continuing on like this loop function to make it go in a series in order. This series of numbers that you've set up for the growth instructions for this specific thing, for this attribute, right? So right, like what is the difference between these two guys? Well, just a slightly different setup for one parameter, and they're kind of still the same, right? So you can imagine that setting this up inside of what I'm going to be doing this very shortly, setting this up inside of a genetic algorithm is going to be something that will make this go completely, well, okay, for instance, these two would probably be related, right? Because their actual distance inside of this parameter space is closer together than like something which I put completely different parameters in here in. So when I'm creating the DNA stuff like this, when I'm creating the genetic stuff for the actual genetic algorithm and evolution and stuff like that, that's all going to be built in there. Right now I'm just doing parameters. I'm trying to get this system to generate the most different variable number of things, and so this is my solution to that, just throwing like these functions into these parameters that start out with a specific value and then have like a limit set up and then some sort of possible frequency or whatever. I'm gonna have this way more cleaned up, so just stay tuned for that. And yeah, that's how that works. You can just keep changing whatever it is that you want, and all of those things will change. As you can see, I had that one like little tiny stick guy by using the square function over there. So that's actually a decent example of what I wanted to do. So that's that. If you have any questions or comments, just let me know in YouTube. I'm also going to be starting a Discord server here pretty soon. If the community allows. And yeah, cheers for all the people who came in here from Reddit. Please, if you're on YouTube, just subscribe to me or whatever, and you'll keep getting updates. And also check out the GitHub. That link is also below. So yeah, talk to you guys next time.